Hello? Hey! This is just a review on how to use the protractor. The protractor is this amazing looking half circle. I want to point out two features of the protractor. First, it's got two rows of numbers. I don't know if you'll notice that, but it's got this is like the top row, and then it's got a bottom row of numbers as well. Now I want you to notice these two protractors I have here are identical. And I'm going to show you two different ways to use the same protractor. Okay, so I also want to point out that on this protractor, let's just say this is protractor number 1, and let's say that this is protractor number 2. Okay, so on protractor number 1, we're going to use top row. Okay, and I want you to notice that the top row starts right here. So this is 0. Okay, and it slowly gets gradually bigger and bigger and bigger. So I'm just going to kind of draw a line through the numbers that we're not going to use on this protractor. And there's really no right or wrong way. There's smarter ways to use a protractor, but no right or wrong. The key is, if you're going to work with the top row of numbers, then you got to stick with the top row of numbers. And if you're going to work with the bottom row of numbers, you got to stick with the bottom row. So let's go over here. Protractor number 2, we're going to work on the bottom row, and I want to point out the bottom row. That's a hard color to see. Let's pick a darker color. Okay, so let's say this is number 2. The bottom row starts right here. So 0 is right here, and it goes all the way across and gets increasingly bigger and bigger. So we're going to mark through that top row, because on this one we're not going to use the top row at all. We have to be consistent. Let me say it again. It doesn't matter whether you start on the top or the bottom, but it's whichever one you use, you have to be consistent. Alright, so we're going to find angles BAC, angles CAE, and angles EAD. We're all going to find those angles using protractor 1 and protractor number 2. So let's start with protractor number 1. Let's find all these angles. So BAC. Alright, BAC is up here. Now, what I want to do before I do anything else is show y'all like a really easy technique to really simplify this process. And it's pretty straightforward. What we're going to do is we're just going to label points B, C, D, and E where they are on the protractor using just the top row. Alright, so B crosses the protractor right here. It's 10 right here, so that's got to be 0. So B is 0 degrees. Bye, Pablo. Bye. C is going to cross the protractor at 40, 50, 60, not quite to 70. We'll just say it's 70. Okay, just to be safe. So that's 70 degrees. It's a 70. Sorry about that. Okay. And then D crosses just past 130, but it's not quite to 135. Let's say 131. 131 degrees, and E passes across 150. Let's say 151. Okay, 151 degrees. All right, let's do the same thing on protractor number 2, and let's just see the difference. Now it's the same protractor, same angles, everything's the same. We're just going to use the bottom row now. So I'm going to start at the 0 over here, 10, 20. Let's see, E crosses between 30 and 20. It's got to be between 30 and 20. Let's say 29. Okay, so E is 29 degrees if we use the bottom row. Now if we use the bottom row for D, it's between 40 and 50. Let's just say 49 degrees. Alright, C crosses right at the 100 mark. So we're going to say that's 100 degrees. Actually, sorry, that's a mistake I made. Glad I caught that. It'll be 110. I know it looks like 100, but 100 is right here. So it's got to be 110. It's an easy mistake to make. Okay. And then B doesn't have a number, but we're going 150, 160, 170, and we go 10 more. 10 more than 170 has got to be 180. So we're going to label that as 180 degrees. It's a straight line with over here. Okay. So these are the two different versions of the same protractor. As long as we're consistent, I'm going to show you how to find the angle. So BAC. So BAC. Well, C equals 70 degrees, and B equals 0 degrees. And if I just find the difference between those, I'm going to get 70 degrees. Alright, so that's angle BAC. Alright, let's see angle CAE. Okay, so E is equal to 151 degrees, and C, which is right here, here's E, is equal to 70 degrees. So I subtract, get 1, and then 15 take away 7 is 8, so it's 81 degrees. Alright, so that's angle CAE. Alright, and finally, angle EAD. Let's do that over here. We kind of ran out of room. I didn't do a good job organizing. I'm really sorry. Alright, E is right here, and D is right here. So E, notice I'm picking the larger of the two numbers first, and that's so that subtraction is easier. And D, which equals 131. And I subtract those two, and I get, see, 1 take away 1, that's 2. I get 20 degrees. Alright, so my angle is 20 degrees for EAD. Alright, now I'm going to show you how you can use the same protractor, but the different row, and still get the same answers. Okay, so let's look at angle B, and C. B is bigger, so I'm going to start with B. B on protractor 2 is 180 degrees, and C equals 110 degrees. Alright, that's going to leave me with 70 degrees. So, does that match protractor number 1? Yes, it does. 70 degrees, 70 degrees. Alright, let's try angle CAE. Okay, E is right here, and C is right here. C is bigger, so we're going to start with C. So we're going to say C equals, and look, it says 110. So I'm going to put 110 degrees, and E equals 29. It's bad form. Let's put the 2 under the tens digit, and the 9 under the ones digit. Now we just subtract. Okay, we have to borrow, so this becomes 10, that becomes 10, so I get 1 and 8, 81 degrees. Let's see, how did we do? Yes, 81 degrees, matches over here, matches over here. Same thing, different technique. The key is I'm consistent. I use the bottom row numbers over here, I use the top row numbers over here, and the last one, you guessed it, will probably be the same, but let's just double check. We're going to do angle EAD. So E is right here, and D is right here. In this case, D is bigger, so we're going to start with D. And D equals 49 degrees. And E equals 29 degrees. Alright, and 49 take away 29 is 20 degrees. Same answer. Alright, so that's the same as this. So there are two different ways to find the same answer. Hopefully this clarifies any misconceptions or confusion that you have. Just out of curiosity, do you know what the measure of each of those angles are? And if you said acute, you are right, because they're all below 90. Can anybody name an angle that is obtuse? Look at the angles up there. There's several options. Which are obtuse? And if you said BAD or BAE, you would be correct. Both of those are obtuse. There's no right angle and there is no straight angle in this case. Okay, but if we did want to make a straight angle, we could extend this line out, call it F, and angle BAF would be 180 degree, it'd be a straight angle. Alright, Have a great day, and thank you for tuning in. Hey kiddos, this is Mr. Nelson here. This is video 10-2. We're going to be talking about angles and a triangle and a quadrilateral. Okay, so we got two pictures here just to review. The quadrilateral, that quad means 4, so it's 4 sides, and the tri for triangle means 3. And in our Discovery Lab earlier today, we discovered that if you take the angle for A and B and C and D for any quadrilateral, it doesn't matter. If you take all 4 angles and you add them together, the total angle should always equal 360 degrees. Okay? And just one way to prove that, if you take a circle and you split the circle like this, okay, and you count up, you've got 1, 2, 3, 4 right angles. All 4 of those right angles are 90 degrees, so 4 times 90 equals 360 degrees. So a circle is 360 degrees. All 4 corners of a quadrilateral, no matter the quadrilateral, whether it's a trapezoid or a rhombus or a square or a rectangle, they're all going to add up to 360 degrees. Alright, that's going to be important, so write that down. The triangle, if you add up all the degrees of the triangle, 1, 2, and 3, so angle A, angle B, and angle C, that will always equal 180 degrees, no matter the type of triangle. Okay. So, let's look at triangles first. There's a couple of special rules that go along with triangles. So let's start with the isosceles triangle. An isosceles triangle, the isosceles means it's got 2 of the same sides. So when you see little marks like this and like this, that means that those 2 sides are the same. So if these 2 sides are the same, that means that these 2 angles are going to be the same. So that means angle C is going to equal angle B. That is one of the rules of triangles. And so if I were to give you angle A, you could take, okay, let's say angle A, angle A equals 40. Okay, I don't know if it does or not, but let's say it does, equals 40 degrees. What you would do is you would say, okay, if the whole triangle is 180 and I take away 40, then what's left is going to be 140 degrees. Okay, those are all degrees. Okay, and I know that angle C and angle B are the only 2 angles left, and they added up have to be 140, so that means that they all have to be equal to 70 degrees because it's half of 140. So if I just divide that 2, that's how I got that. Okay, so isosceles triangles, 2 of the same sides, 2 of the same angles, angle C and angle B. Alright, now scalene, none of the angles are going to be the same because all the sides are different. So angle A does not equal angle B, which does not equal angle C. Alright, equilateral triangle, all 3 sides are the same, so you guessed it, all 3 angles, angle B, angle C, and angle A are going to equal each other. So angle A equals angle B, which equals angle C. So if we have a triangle, it's 180 degrees total, and we just divide it equally among 3 different angles. 3 goes into 1 no times, but it goes into 18 6 times. 6 times 3 is 18. Bring down the 0. 3 goes into 0 0 times. That means each angle is 60 degrees. No matter what equilateral triangle, they are always equal 60 degrees. Alright, and last we have a right triangle, and all that we need to know is if you see this sign right here, that tells us that this is 90 degrees. So we can use that as clues. So if I went in here and told you that angle triangles. So angle A equals, I don't know, let's say 60 degrees. Then I know this is 90, this is 60 degrees. That means this would have to be whatever's left over out of 180. So I add up 90 and 60. That gives me 150. So I have 180 degrees. Take away 150 degrees. And that means angle B is everything that's left over, which is 30 degrees. So angle B has to equal 30 degrees there. Okay, because if I add up all the angles, it's got to be 180. Every triangle has got to be 180. So we have to use that rule of the 180 to solve for these triangles. Okay, and we see that 180 rule right here. We see the 180 rule right here. And we see that 180 once again show up right here. Okay. Let's look at these shapes right here. These are quadrilaterals. These are different examples of quadrilaterals. Okay, and these shapes right here, you should be familiar with all of these quadrilaterals, but in case you aren't, let me perform a little bit of magic here. Bippity, boppity, boo! Alright, this top shape up here is called a trapezium, because none of the sides are parallel at all, and the only thing that we know about this for sure is that all the angles added up have to still be 360 degrees. Now for the trapezoid, two sides are parallel, so we show parallel by showing these little arrows. Those two sides are parallel. The other two sides are not. Now if the non-parallel sides, so this side and this side, are the same, okay, that means that angle, let's see, let's pick a color. Okay, that means this angle A and B are going to be equal to each other, and angle C and D are going to be equal to each other. Okay, so off to the side here, just make a little note that if the trapezoid is an isosceles trapezoid, that means the two sides are the same, the non-parallel sides, that angle A will equal angle B, okay, and angle C will equal angle D. Alright, on a parallelogram, that means the opposite sides are the same length and they're parallel, and so this and this are the same length, and this and this are the same length, and this is parallel with this. Put 2 on there. So these two are parallel, and this is parallel. Okay, what we're going to find out is if I number these and I say, okay, this is angle A, B, C, and D, the opposite angles are going to be identical. So that means angle A and C are going to equal each other. So angle A will equal angle C, and angle D will equal the opposite angle, angle B. So angle, that's not how we show angle. Our little slip there. Angle D will equal angle B. Okay, and still the rule applies. 360 degrees total. Same with this one, 360 degrees total and 360 degrees total. All quadrilaterals are 360 degrees total. Alright, the rhombus. Rhombus is just a type of parallelogram, and what defines a rhombus is that all the sides here are equal and the opposite sides are going to be parallel. So this side and this side are parallel, and this side and this side are going to be parallel. Okay. Once again, the opposite angles are going to be equal. So if I number these angles, A, B, C, and D, The same rules apply as a parallelogram. Same. Okay? The rectangle. Rectangle is defined because these sides, opposite sides, are the same length and every angle is 90. Okay, so all angles equal 90 degrees. And just like all the previous ones, 4 times 90 degrees, because there's 4 angles, multiply them all by 90, that's going to equal 360 degrees. Alright, and then the square is the same. Same. Alright, let's take a look at a couple problems. Okay, and we have to use what we know. So this is a quadrilateral. So we know that if I take all angles added up, so the sum, that's not how you spell sum, equals 360 degrees. Okay? Alright, we also know that this symbol right here means 90 degrees, and this symbol right here means 90 degrees. So if I just add up these 3 angles and I take it away from 360, I'll be able to find F. Okay, so let's check it out. 90 plus 90 is 180. So let's do 115 plus 180. Alright. Now I take 360, which I know all the angles need to equal 360. I'll take 360 degrees. Make sure you add your degrees on there. My bad. And I take away all 3 of these angles. I'm left with the final angle. Okay, so max borrowing 2. This will be 15. This will be 10. 5, 6, 1. Okay, so that's 165. So 165 degrees. That means F equals, angle F equals 165 degrees. Okay, so what did I use to solve? Well, I used this rule right here, and then I just took away the angles that were given. Took away 90, took away 90, took away 115, and I'm left with F. Okay, alright, this shape right here, it's a triangle, it's a special triangle. What do these little red marks mean? They mean that the 2 sides are the same. That's an isosceles triangle. So that means that angle A and angle B are the same. So if I told you that angle C equals, I don't know, 80 degrees, okay? Well, what information do I know? I know that all triangles, their angles added together is going to equal 180 degrees. So if I take away C, I'm left with A and B. So let's try that. Let's see what we get. So I start with all the angles, 180. I take away angle C, and these are in degrees. Okay, and that leaves me with 100 degrees. And I know that because this is an isosceles, I know that A and B are going to be equal to each other. These 2 sides are the same. These 2 angles right here are going to be the same. So if they're the same and I have 100, I can just split that in half. So do 100 degrees. I divide it in half. Divide it by 2. Bring it down. And so that means 50 degrees. So angle A and angle B equal 50 degrees. Alright. Cool. Last problem. What is the measure of angle PSR? Okay, so I've got a quadrilateral, and I also have a triangle. I don't know if y'all notice a triangle. Triangle is P to T to S and to R. Okay, So we're going to use our clues that we're given to solve for this whole thing. So what we're trying to really identify is angle PSR. So P to S to R. So we don't know this angle. Okay. So first off, we know this angle right here. It's a right angle. It's right angle up here. These two sides are parallel. So if line T is parallel to this line, then it's got to be parallel to this line because it's a trapezoid. Okay, so that's 90 degrees. So the only thing left for us to find is this angle right here. Okay, so if we can find this angle right here, we can add it to the 90 degrees right here, and we'll know what our angle is. Okay, so we're dealing with a triangle here, and we know all triangles, the sum of their angles equals 180 degrees. Okay, I know that that angle is 90, and this angle right here is 60. So 90 plus 60 degrees equals 150 degrees. So if the whole triangle is 180, but these two are 150, what's left over? Well, it's a simple little subtraction problem. 180 degrees, take away 150 degrees, and I'm left over with 30 degrees. So that means this angle right here is 30 degrees. So the whole angle, P to S to R, is going to be this angle plus this angle. So it's going to be 90 degrees plus the 30 degrees, 120 degrees. All right, so angle PSR equals 120 degrees. Okay, that's our answer. But we can also double check, because if this side and this side are equal, and this is 60, that means this has to be 60, and that means this has to be 120 as well. 120 plus 120 is 240. 240 degrees, and 60 plus 60 equals 120 degrees. And since it's a quadrilateral, shouldn't all the angles add up to be 360 degrees? Yes, they should. So let's see. 0 degrees, 6 degrees, 360 degrees. Alright, all these angles check out. And all we're using is this rule right here and this rule right here. So a square is 360 degrees, a triangle is 180 degrees. So you have to use the clues that are given. If you can identify right angles and the other angles, and you can use these two little clues right here, you can solve any one of these problems. Now, had you known this information for the pretest, you would have done just fine. But I feel like with this information now, you're going to be just fine for tomorrow's activity. Thanks and have a good night.